Hi guys, this is Pre-Algebra Lesson 2-1. Yes, we're continuing with Lesson 1, Rational Numbers as Decimals. In this lesson, we'll be able to write repeating decimals as fractions. Let's start with solve and discuss it. Jalen has a wrench labeled 0.1875 inch and bolts labeled in fractions of an inch. Which size bolt will fit best with the wrench? Explain. So if you have a wrench that has 0.1875 inches, you want to find a bolt that fits the size of that wrench so that your wrench is not too big or too small to fit it, right? It has to be exactly fit so that you can use it to turn it around and screw it in your bike. But the problem is that all the bolts are in fractions. How do you know if the sizes are the same as this decimal? Well, you can either convert this decimal into a fraction, or you can convert all these fractions into decimals. What do you want to do? If you want to just convert this decimal into a fraction and compare it with other fractions, that's fine. Do you know how to convert a decimal into a fraction? You have to look at the place value. There are 1, 2, 3, 4 place values. So that's tens, hundreds, thousands, 10,000s, right? So you're going to add zeros for each place values and make it into a fraction. 1,875 over 10,000. And then you're going to simplify that fraction. And that could be, both of the numbers could be divided by the same number, let's say 5, to get 375 over 2,000. And then you can simplify that even further by dividing it by 5 again. You get 75 over 400. Divide that by 5 again, 15 over 80. Divide that by 5 again, you get 3 over 16, and that is simplified. And you see 3 over 16 bolt here. So that size would fit your wrench the best. Okay? Other way is when you can convert your fractions into decimals. If you're more comfortable with converting fractions to decimals, then you convert each of them. But you have to convert everything to see which size fits the best. So 3 over 8, how do you convert fractions to a decimal? You literally divide the numerator with the denominator. So 3 divided by 8 will give you a decimal equivalent to that fraction. That's 0.187, wait, 3 divided by 8, no. 3 divided by 8 should be 0.375. Yeah. And then 1 divided by 8 is your next bolt, and that's going to be 0.125. 3 divided by 16 will finally be 0.1875. 1 divided by 4 is 0.25. Okay, so when you convert all the fractions into decimals, you can see that only this bolt fits your wrench perfectly. So how can you write these numbers into the same form? Either convert the decimal into fraction or convert fractions into decimal. Okay, so we can answer this reasoning question. We can convert fractions into decimals or convert the decimal into a fraction. Okay. Focus on math practices. Why is it useful to write a rational number as a fraction or as a decimal? Why is it useful? Why did we do that? Otherwise, can you just look at the decimal and fractions and tell which one is fit for each other? No, it's really hard to compare them if they're not in the same form. So that's the whole idea of converting them into the same form so that you can compare them easily. All right. So we can say it is easier to compare rational numbers if you can write each in the same form. And this also happens when you write a really large number and a really small number into scientific notation. That's when you use scientific notation to compare them, and we'll talk about it at the end of the topic. But this lesson highlights how can you write repeating decimals as fractions. So we'll talk about how we write repeating decimals as fractions. What if your decimals are repeating and it repeats over and over and over again, and you can't really write it into a fraction right away, right? There are infinitely many place values that you can have, right? There's a trick to this method. So let's look at example 1. Write repeating decimals as fractions. Example comes with this problem. The Sluggers baseball team ended the season with the highest win percentage in their division. What is the Sluggers winning percentage written as a fraction? So this is a percentage, and percentages could be written in decimal or a whole number in a percentage, right? This means you have 55.6 percentage win. 0.512 represents 51.2%, and so on, right? So statistics are often rounded. So here the decimal is 0.555 repeated, or 0.5 is rounded to the thousandth place. So we're going to locate 0.555 ... on a number line, so repeating decimal. The decimal number is 0.555 repeated, and that's between 0.5 and 0.6. It's somewhere between here, right? So it's between 1/2 or 5/10 and 6/10. So we know what it should approximately look like and where it should approximately be. But how do you exactly write them into a fraction? So first, we're going to write the repeating decimal as a fraction by assigning a variable to represent the repeating decimal. Why do we need this? You'll see. So let x represent your repeating decimal, 0.555 repeated, right? And then you're going to multiply tens by the place value. So if your 5 is in the place value of tens, you multiply 10. If you have 2 digits that are repeating and they're in the hundreds, and your repeating digit ends in the hundreds place, then you multiply hundreds. So whatever you're multiplying depends on the place value where your repeating digits end. Because 0.5 has one repeating digit, you're going to multiply each side with 10, okay? You'll see why. Then you multiply and get 10x is equal to 10 times 0.5 repeated is 5.5 repeated, right? 5 is repeated, but we're going to make 5 into a whole number and say, oh, we can get a repeating decimal here. And then we're going to subtract x on both sides. What does x represent? X represents 0.5 repeating decimal, right? So 10x minus x is 9x. But we can say 5.5 repeated minus 0.5 repeated instead of minus x, because they're actually the same thing. So there's where the trick comes from. Instead of subtracting x as a variable on both sides, you're going to substitute x with 0.5 repeating decimal to get rid of the repeating decimal. And that's magical. Now we have 9x equals 5, and they're all whole numbers. We don't have repeating decimals now. Now we can solve for x and say, oh, x is just simply 5 over 9. And you know x has to represent 0.5 repeated. So if x is equal to, simplify it to a fraction 5 over 9, 5 over 9 is equal to 0.5 repeated. There you go. Repeating decimal written as a fraction. The Sluggers won 5 over 9 of their games. Okay. I know it's going to take a little bit of time and practice if this is your first time learning this. So here's your try it. Try this question. In another baseball division, one team had a winning percentage of 0.444 repeated. What fraction of their games did this team win? Basically, write the repeating decimal into a fraction and fill in these blanks to solve it step by step. See if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? So, first, what do? You assign x to equal the repeating decimal. How many digits are repeating? You have one digit repeating. And that's on the tens place, right? So you're going to multiply 10. So 10 times x and 10 times 0.4 repeated. You get 10x. And 10 times 0.4 repeated is 4.4 repeated. And you subtract 10x by x. And x is equal to 0.4 repeated. So on this side, you're going to subtract 0.4 repeated. Okay? That's the same as subtracting x on both sides. So then 4.4 repeated minus 0.4 repeated gets rid of the repeating decimal, and you get a nice little whole number, 4. And 10x minus x is 9x. So x is equal to 4 divided by 9. So your repeating decimal, 0.4 repeated, is equivalent to the fraction 4 over 9. The team won 4 over 9 of their games. Easy. Convince me, how do you know what power of 10 to multiply by in the second step at the right? How do you know which power of 10 you should multiply? We talked about this. How do you know? You look at the digit, how many digits your repeating decimal has, and where the place value ends when you put it into a nice little 0 point repeating decimal, right? So you're going to multiply by the power by 10 because 0.444 repeated has one repeating digit. Okay, if you have 2 repeating digits, you multiply by 100. If you have 3 repeating digits, you multiply by 1,000. Whatever number you have for the repeating digit, you add a 0. Okay, that's how many zeros with the power of 10 you're multiplying. Okay, let's look at example 2. Write repeating decimals with non-repeating digits as fractions. What if you have a digit that is not repeating and then you have a repeating decimal later? This is the rule for solving that. Sabine entered a division expression into her calculator. The quotient is shown on the calculator screen. What expression could Sabine have entered? So we want to figure out what fraction she used in order to get a decimal here. We're going to let x equal to this repeating decimal again. Okay, x is 0.266666 repeated. We're going to multiply it by 10 because how many digit is repeating? 1. One number repeating decimal, repeating digit, right? So we're going to multiply by 10. 2 doesn't count because 2 is not repeating. And then you do the same thing. You subtract x on both sides, except you're going to substitute 0.26 repeated as your x. And now you just simply subtract 0.26. So it's going to look a little bit different when you subtract the decimals, because 2.666 repeated minus 0.2666 repeated is, you subtract all of these, but then 6 minus 2 is 4. And then 2 minus 0 is 2. So you don't get a nice little whole number, but you get a nice little terminating decimal. And that's what you want, 2.4. So 9x is equal to 2.4, and now you can divide 2.4 by 9, and your fraction, simplified, you need to get rid of that decimal. When you simplify that fraction, you get 24 over 90. You just multiply both of them by 10. So she could have entered 24 divided by 90, or that could have been simplified to 8 over 30. And so equivalent expressions such as 8 divided by 30. Okay? Now it's your turn. Write the repeating decimal 0.633333 repeated as a fraction. See if you can write this repeating decimal into a fraction by yourself. Come back when you're ready for checking your answers. Okay, are you ready? So you're going to do the same thing. What's the first step of writing this into a fraction? You have to assign it a variable. So 0.63333 dot 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 is equivalent to x. And then you multiply both sides by how many digits do you have as a repeating decimal? You have one repeating digit, 3. 6 is not repeating, so you don't count that. So you're going to multiply by 10. You get 6.333 dot 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 equals 10x. Okay, multiply 10 on both sides. And then you subtract x on both sides. 6.333 dot 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 minus x is equal to this. You're going to subtract this decimal. 0.6333 repeated, and 10x minus x. So you have 9x is equivalent to 6.333 repeated minus 0.6333 repeated. Make sure your place values are aligned. So you get rid of all the repeated 3's, but then, right, repeated 3's. But then 3 minus 6 is going to give you 7 if you borrow 10s from the 6. And that's going to be 5. So 5.7 is the terminating decimal you get. And your x is equal to 5.7 divided by 9. And you can simplify that to 57 over 90. And you can simplify that to 19 over 30. So write repeating decimals 0.6333 as a fraction. You can say 57 over 90 or 19 over 30. Okay, let's look at example 3. Write decimals with multiple repeating digits as fractions. We're going to write 2.09 where 0.9 is repeated, 0 and 9 are repeated as a mixed number. Okay, so we're gonna go through the same steps, except how many repeating digits do we have? 0 and 2. We have 2 repeating digits. So on the second step here, we're gonna multiply hundreds. We're gonna multiply 2 zeros. Okay, so 100x equals 100 times 0.090909 dot dot dot. And so we get 209.09 repeated when we multiply that. Then we're gonna subtract x on both sides, right? So I think there's a step missing. You can say 100x is equal to 209.09 repeated. Then you subtract x on both sides, except you're gonna subtract this one here instead of x because they're equal to each other. You get 99x is equal to 207. and x is exactly 207 over 99, or you can change this into a mixed fraction. 99 times 2 is 198, right? 198. So then you subtract 207 by 198 and get 9. And so 2 and 9 over 99, it would be simplified to 2 and 1 over 11. Okay, divide both numerator and denominator by 9, and you get 1 over 11. Okay, now it's your turn. Try number 3. Write the repeating decimal 4.1363636 ... as a fraction. It is very important to note how many digits are repeated. See if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Yeah, so it's a little bit different here. First, but the steps are all the same, okay? First, assign your x to your repeating decimal. 4.1363636. So your 36 is repeating, right? And so because there are 2 digits that are repeating, you're going to multiply by 100 on both sides. So 100x is equal to 100 times 4.136 repeated is 413.6 and 3636 repeated, right? So you have repeating here. If you have a decimal point, you don't have, it's better not to put a bar over it. Okay, it's not pretty. And then you're going to subtract x on both sides. So 100x minus x is equal to 413.636 repeated minus 4.136 repeated. So you have 99x, and if you subtract 413.636 repeated by 4.136 repeated, you see how they're all lined up for the repeating decimals? That's why we have multiplied hundreds on both sides, okay? You get rid of that. They're gone. So 6 minus 1 is 5, 3 minus 4 is 9, and you get it from 1, and so you get 409.5. And so that's 409.5. And x is equal to 409.5 over 99, which is 4,095 over 990. And if you multiply 990 by 4, you will get 3,960. So if you subtract 4,095 by 3,960, that's the remaining you have when you try to change it to a mixed number. So 135, you get 4 and 135 out of 990. And you can simplify that even further and say 4 and 3 over 22. So write this as a fraction. You have 4 and 3 over 22. That is your final answer. Okay, so we have learned how to write repeating decimals into fractions. So let's summarize our lesson. Because repeating decimals are rational numbers, you can write them in fraction form. So step 1, assign a variable to represent your repeating decimal. And then you're going to write an equation, variable equals decimal. And multiply each side of the equation by 10 to the power of d, where d is the number of repeating digits in the repeating decimal. Okay? Subtract equivalent expressions of the variable and the repeating decimal from each side of the equation. You're going to subtract. Solve for the variable, write an equivalent fraction so that the numerator and denominator are integers, if necessary. So simplify your fractions at the end. Okay, that was lesson 2-1, rational numbers as decimals. If you have any more questions, please feel free to ask Ms. Kang in class. Otherwise, we'll continue with lesson 2, understand irrational numbers, in the next video. Thanks for watching. Bye!